Good afternoon, all. A warm welcome to the program, International Training and Internship Program. This is Mukesh from Tech Counselor team, and I welcome to all the audience as well as my expert and Dr. Semwal, Ms. Priyanka, as well as to Naveen Kumar sir. Thank you for accepting our request to the session. I am very much thankful to Tulas Institute of Technology and to the Tech Counselor Group for organizing such a wonderful program. Then we have our co-organizer, Krishna Institute of Medical Science, deemed to be university from Maharashtra. We also have Uttarakhand Technical University with us as a technical partner. And for the industry and technical part, for the knowledge partner and technical partner, we have Yuvayana Tech and Craft Private Limited, Ramanujan Academy of Science and Technology. Then we have Swachh Group with us. Also, we have Boudik Ventures providing IP support, and then we have Kaviraj Foundation, our CSR partner, and Trides. So I'm very much thankful for my whole team for organizing this wonderful session, which we started on 20th of June and will be going on till 15th of July. Semal sir, can you put the next slide? Yeah. So we have conducted this program in line with the government of India vision and mission to make India a global R&D hub. So we have various experts, and we already have conducted 7 seminars for so far. We already had Mr. Madan Kanala, who is the founder and CEO for SNOM, Ottawa from Canada. We also had Dr. Raman Sharma, who is the senior scientist at CSR India. Then we had Dr. Rajkumar Haldar, who is the CEO and founder for Revenal Biomedical OPC Private Limited from New Delhi. We had very senior Professor Dr. Manoj Panda, who is the professor at Govind Ballabh Pant Institute of Engineering Technology, as well as state project advisor, administrator for state project implementation unit, Uttarakhand. So yesterday we had Naveen Kumar sir with us. Today we have Naveen Kumar with us. He's a research engineer working at one of the lab in France. Then we will also have Siparda Prasad in the coming days, Vinay Chaudhary, a very senior professor, Dr. Sunil Semwal, who is the HOD and professor at Electrical Engineering, Tulas Institute, Dehradun. Also, Ajit Kumar Yadav, researcher at NISA project, a joint initiative between NASA and ISRO, will also be joining us. He is the founder for Ramanujan Academy of Science and Technology. Also, Sara Trivedi sir has already given lecture on IP and its value, its addition for the startups. He is the founder and director for Boudik Ventures Private Limited. Udayveer Mittal will be joining us. He is the founder and director for
Hello. Hello.
will be hosting. Yes, sir.
Okay.
Hello.
Yeah. So I will hand over the session to Dr. Sunil Semwal to kindly introduce Naveen Kumar sir for the session, and we hope that this will be like a wonderful session for the expert and for our audience. So handing over to you, sir.
Oh, no, thank you, Mukesh. I am Dr. Sunil Saimal, organizing secretary of this event. Today we have with us research engineer Mr. Naveen Kumar. He is working in France in a reputed laboratory and working in the area of antenna for railway design. The project is Shift to Rail project, in which he is working as a research engineer. Mr. Naveen received his master degree, his PhD degree from Thapar Institute of Technology and master degree from NITTR Chandigarh in 2013. He is BTech from SBIET Punjab, and he is an innovator. He is a researcher in the area of antenna design. He has several papers in IEEE transaction and reputed journal, and his currently his work is antenna design and MIMO antenna and wireless communication. So I am handovering the session to Mr. Naveen Kumar. Hello, sir.
Yeah, thank you. Thank you, Dr. Semwal. Thank you, the organizers. I'm happy to be here, and thank you for inviting me to share my experience, some insights that I have in the field of antennas, which are being used worldwide for different applications. And nowadays we are having so many devices around us which are communicating with each other, right? So making a smart home, a smart city around us, right? So thank you very much, Tech Counselor, the organizers, Tulas Institute, and the other partners who are supporting this event. So I'll be starting off with the presentation by sharing my screen, and you confirm if the screen is visible. Is it right? Visible? Hello?
Visible.
Hello?
Hello.
Okay.
Naveen,
Thank you. Thank you very much. I was just waiting for the feedback.
Not visible.
Yes?
Not visible. The screen is not visible.
Not visible?
Yeah.
Okay. Okay, 1 second. I'll just... Okay, I guess now it should be...
Yes. Now visible.
Is it visible now?
Yeah. Yeah. Yes. Antenna for
Okay.
IoT and wearable
Okay,
device.
thank you. Thank you very much. So I can start now.
Yeah.
Yeah, correct. Thank you very much. So I'll start now. First of all, good morning, good afternoon, and good evening, those who are watching this webinar from different parts of the world. And the talk that I'll be having today is on antennas for IoT and wearable devices for connected world. I am working here as a research engineer in France in the lab, which is the Institute of Research and Technology, Railenium. And the company actually works in the area of railway transport, the research in that area, specifically working on different projects which are national, which are from France, as well as on the European level. So there are many contributors, partners, which are working in collaboration with this lab to design and develop new technologies or new innovations which will be there in the coming years to be used in railways, as well as for the passengers who will be using the railway system. So to start with, this will be the outline of the presentation. And before that, I'll just say a special hi to someone who is watching this webinar. So to start with, the outline will be to have a brief idea what is the connected world. What do we mean by connected world? And then going forward with the IoT basics, how we understand the IoT domain, as well as the antennas used in these IoT technologies. Next, what are the antenna requirements? A very brief discussion about it, because I know that the audience will be from different genres and different domains. So it will be easier for them to understand if we'll just touch on these topics. So the antenna requirements specifically for the IoT devices. Then we move on to wearable antennas, which is actually a special case in IoT umbrella. So wearable antenna is nothing much, is just a special usage of IoT systems which we can wear or which we can carry with ourselves. So some basics about wearable antennas, the inside structures and how they work, and also the requirements specifically for the wearables, because we'll be carrying them or we'll be having them on our body. So what are the specific requirements? And finally, the conclusion of the talk. So to start with, let's see what is the connected world. What does it mean to us? So connected world is basically all about what we hear these days, the new terms like IoT, AI, artificial intelligence, deep learning, machine learning. We are also hearing something like SATCOM, which is like approachable to common public. Companies like SpaceX, they are developing the very, very interesting project Starlink. In the last few weeks, there was some buzz about it. They were launching hundreds of satellites, forming a satellite network in the lower Earth orbit, which we call LEO, so that they can connect, they can provide broadband services to the public quite easily. And there are some other companies also who are having this kind of vision, who are already working on it, who are deploying a large number of satellites, small satellites, which we call CubeSats, a very small 10 centimeter by 10 centimeter size satellite. And we have hundreds of them in the orbit, and through that we can have the internet available. So a connected world is to have everything with us, around us, being connected. Whether it's about the transport that we use, the car that we drive, the devices that we use at home or in the office, the hospitals being smart, the buildings being smart, everything being connected or communicating with each other, getting information, giving information, processing information. So all in all, connected world is to have everything connected with each other. And in this way, we can also term this idea to be Internet of Everything, which is IoE. It means humans connected with machines or devices or gadgets, and they are also being interconnected with each other. So this forms an interesting concept which we call Internet of Everything, right? So in this fascinating world, in this always changing world, the things that we are getting these days, new innovations, new products, we are seeing that this is becoming reality. Whatever we saw in the last decades in movies, Hollywood movies, or some sci-fi fiction, we are experiencing all of that. Whether it be like a smartphone, using smartphone for doing stuff, getting stuff, monitoring stuff, and operating our household items like lighting, air conditioner, cars. So we can do that by our smartphones. So in that sense, we are on the path of being connected. And in the coming years, with the introduction of 5G being deployed all around, we will be seeing much more of these kind of connections or these kind of networks around us. So moving ahead, we can start with the IoT basics and the antennas which are being used in these. Very brief, a very general introduction to all these topics and domains. So to start with, this slide can give you a better picture. What are the drivers of Internet of Things? What are the requirements, or we can say backup technologies or backup things that we need to drive the Internet of Things innovation or productions of so many products? So to start with, if we see here, first thing is 3GPP standards. Although as of now there is not one international standard which we say that it is for Internet of Things. The association or the alliance, sorry, the Alliance 3GPP is actually working towards different standards. They are releasing every year some modifications in different standards, like in 4G, 5G, as well as Wi-Fi. They have introduced special sections or standards specifically for IoT, the IoT operation protocols and everything. So we need that standards for sure. We have to have that. Then we have to have expanded internet connectivity. It's not like we will have all these things, all these devices, and still people in many countries are not connected. They are not using internet very much. So with the advent of new technologies, with the introduction of new communication technologies, with the upcoming 5G, we are looking forward to connect everyone, to have everyone be on the internet, right? With the smartphones being cheap, with the technologies being accessible, and the data rate being cheap, we think that, or we estimate that, I guess everyone will be connected, and in that sense we will have the proper usage of this Internet of Things working all fine. Then we should have high mobile adoption. It is linked with the again with the popularizing concept of everyone being connected. So high mobile adoption means, again, everyone has to have a smartphone, everyone has to be connected, having the internet connection on the smartphone, and in that sense it will make the whole IoT network, IoT domain. Then along with that, IoT is not just about things being connected to internet. I'll in the coming slide I'll explain a bit the difference between all these terms. So it's not about just things being connected, objects being connected to internet. It's about having sensors, having devices which will gather data, which will acquire data, and on which processing can be done. So low-cost sensors is also a driving force to IoT. If there will be a low-cost sensor availability, there will be much more IoT devices coming up. There will be variety of devices which will be there in the market from different companies, of course, and different kind of sensors in them. Then, of course, from the companies, from the developers, from the product manufacturers, there has to be a large IoT investment required. Already companies like Qualcomm, Intel, Samsung, and many big names are are investing in their productions, in their manufacturing methodologies to be ready for the IoT demand, because a lot of processing power, a lot of sensors, and so many different sections and ICs will be required when an IoT system will be developed for a particular product or for a particular application. So a large amount of IoT investment will be required from big players as well as from the startups who will be working in this domain. There are already hundreds of startups in the IoT domain, but in future we'll be requiring them to game up a bit and to increase their investment for sure, because the public demand will increase as the number of devices will increase, right? Then there is another driver, which is global application trends. It means in particular country, in a particular region, what kind of applications are required, what kind of specific devices which are needed. So in that sense, it drives innovation. It drives the local startups and companies to manufacture Internet of Things. So global application trends is another driving force. Then we have emergence of new technologies, as I mentioned, 5G coming up to our cities and to our countries. Many of the world cities have already deployed the 5G networks, and many of others will also be deploying in the coming months and next year for sure. So with the emerging new technologies, we are sure that we'll be getting much more stable and reliable as well as fast network in terms of data as well as in terms of efficiency. So this also leads to the Internet of Things development. And then again, another important term in Internet of Things is big data. It's about data analytics or data processing, because sensors does what? They gather data, they gather some physical information, and they produce it in the data form, and that has to be processed. So there is a big importance of automation as well as big data analytics and knowledge that drives Internet of Things. Then we have the very popular terms these days, artificial intelligence and machine learning, which will also drive Internet of Things in the coming months. There are already so many devices and gadgets available which forms Internet of Things and works on artificial intelligence and machine learning. Then we have another important term from computers, which is edge computing, and cloud is, I guess everyone knows cloud, what is that? But there is another term, edge computing, which is basically distributed computing. Means you will have multiple devices giving their computation power, and with that power, the computation, along with the local data storage, which is present to the location where it is required, forms the edge computing. That's why the term edge. Edge is for like a local region or local space where you have the computation as well as the data storage, both present there. It's not like there is a remote server, remote storage, and you have a computation with you and then you communicate over the network. Both the things should be local. So that forms edge computing. And cloud, we all know, everything available on cloud can be shared worldwide quite easily, and it can be shared between devices. Then we have some use cases across various domains, vertical domains. Here we mean that we have so many engineering fields or domains or different areas of life where we'll be having use cases of Internet of Things or devices based on that. And it's possible that one kind of a device can be applicable to multiple domains. So we will have multiple use cases around that, and that drives the development of Internet of Things. Then another important aspect which is being worked on, and computer guys are, I guess they are onto it, it's about the security aspect. The security assurance using the gadgets and devices is very important. If you are connected to internet and you are using your gadgets and devices, you're communicating with them, then security is foremost, and it is very important for privacy of everyone, right? Then we have a new internet protocol version 6 that I guess we are already using it in day-to-day life. I guess in the last few years we have already transformed our websites and network on this version. So IoT will also be benefiting from it, IPv6, so that more number of devices can be connected. There will be billions of devices which will be there in the world in the coming years based on IoT, and of course it will require the IP addresses. So IP version 6 will drive that large support of devices. Then we have another important concept, which is open source for 5G. 5G is being standardized. 5G is being developed. 5G is being deployed. Yes, but there is another section of industry which is working on having some open source technologies for 5G. What is open source? Open source is like to have something, software or hardware, information about it available to everyone, and anyone can work on it and modify it as per their own requirement. So for 5G networks also, or 5G technologies or protocols or modulation schemes, anything in 5G, if it being open source or some section of it being open source, it will help to have more customized solutions. It will help us to have more focused solutions in terms of IoT. So this whole group of things or drivers will help us to have more focused, dedicated, specialized IoT devices and gadgets to be available to us, affordable, and then we can use them for our day-to-day operations, right? So moving forward, this will just give you a simplified IoT topology, how it is arranged overall. And on the bottom side, you can see the different layers. Those who are from computers and electronics, they can understand there are 7 layers in the open source model that we have, interface model. So we have device layer, data center, and app layer, and application layer. So in on the left side, you can see there are things we call things in IoT, right? So things are actually the gadgets or devices or the circuits which has sensors, actuators. Sensors are those who gather data, who converts data into digital form, and actuators are those who works on that data, who gets commands to do something, right? To do some operation. So some brief application areas can be industrial. In the industries, can be home, having several kind of devices at home being operated and being connected, and some wearables like smartwatches or smartphones or some trackers and those kind of stuff. So all these things being there, having sensors and actuators as well, and then they are connected to networks. Like in the first example from industry, we can see we can have short range connectivity using Zigbee technology. Zigbee is also very popular among, I guess, project makers, or even in the industry, it's quite popular. It's a short range connectivity technology working on 2.4 gigahertz as Wi-Fi, and it gives an option to have a large number of devices being connected in a short range domain. So that through that connectivity, the industrial sensors or things will be connected to an industrial gateway, which is basically a router kind of a thing. And after which it can be connected to the internet, because everything has to be connected to internet, right, in the end. So it can be connected to internet by using some long range connectivity, which is most popularly nowadays is LTE, 4G. And in the coming years, it will be 5G, right? So through that, it can be connected to internet. And finally, it can connect to data centers or data servers where the data can be stored, because it's not possible to have a large amount of data being stored locally all the time. So data centers or data servers are required, provided by several big companies like Amazon, Google, and all those names. So we will have security, networking, storage, memory provided by that data center especially. And finally, some business applications can be there which can work on that data and can provide us some information or some processed results. Second case can be wearables. Again, through wearables, we can say that the home devices, we can say that in our home we have AC, TV, some we can say refrigerator, some more devices like smart speakers and all. They're all connected to internet through the local router that we have in our home, provided by some service provider, which are local telecom companies. And finally, again, that kind of a data which is gathered by these devices can also be stored in the data center. And finally, from the wearables that we use, I guess most of us are quite exposed to these kind of technologies these days. So we are using all these smartwatches or trackers with us every day. So that can be connected, as we know, that can be connected to our mobile phone first, which is a short range connectivity, mostly via Bluetooth. And further, through mobile phone, it gets connected to internet. And of course, in the end, the data can be again stored to the servers, the specific servers of the app companies that we use, or again to the big servers of big names like Amazon and Google. So this is a simplified topology of how an IoT scenario or IoT network works. And the most common kind of technology, if we see here the connection technologies on the top right, they are the Bluetooth low energy or low power, the special version for IoT. Zigbee, Z-Wave, another variation of Wi-Fi, which is for short-range connectivity. Then we have this technology, which is also called Wi-Fi Hello. Again, it is for low power operation, especially for IoT. And then we have NFC. I guess most of the smartphones also have this near field communication, NFC thing, through which we can pay without having the credit card with us, or we can transfer files into the nearby phones. So all these kind of stuff. So moving ahead, the types of products in IoT. So in IoT domain, we can start with the products which we call smart. These kind of products are being used, I guess, since last couple of decades. We are using these products already. They are connected to internet and they have some sensors and they show some data or some information out of it. That's it. So they are smart. They are connected to internet and they do some kind of data gathering. But then we have connected products or connected devices. Connected is just being connected to internet. That's it. There is nothing else that is being done through that object or gadget. It's just that it's connected to internet. That's it. So this is another kind. But IoT is actually both like smart, connected, as well as it has third component, which we call software defined product, SDP. So there is always a software, or we can say brain, in an IoT product, which does or which manages all these operations. So IoT product will be connected, yes. IoT product will be smart, yes, based on software code or algorithm that we have in it. So the main function of an IoT product is to collect data, transform data, getting all the values from physical sensors and all, and then transforming it into digital form, and then processing it. There will also be some kind of a processing if it will be required. And finally, having that data processed and getting some information out of it, and having that information used to drive something like actuators or displaying something that we want to see. So this is how it works. So a brief example can be the smartwatch that we use for tracking our steps. So it has the sensor, gyro sensor in it. So when we walk, the gyro sensor, because of the movement, it gets the count of steps that we are taking. The movement is a physical thing. The sensor is detecting it. It is counting the steps based on it. And those kind of pulses that it gets from the movement is being converted into digital pulses or digital bits. And those bits are being counted by the internal processing circuitry. And finally, we are just seeing a number being increased, the numerical values being increased on our smartphones or maybe in the watch itself. So in this way, this IoT device works. It has these three components, which is sensors, gathering data, processing unit, which processes that, and finally these actuators or displaying unit, all being connected to internet. Now to go into antennas, that is like quite interesting, maybe to some of you, like to go into antennas, because these are most important components in these devices, because if they have to be connected to internet, of course they have to have a medium to connect to the internet. So antennas are the components which connects wirelessly to other devices as well as the internet in the end, of course. So I'll just give you a brief perspective on antennas here. In this slide, we can see there are two antennas. On the left, there is a very popular Yagi-Uda antenna, and this kind of antenna we were using, I guess, few years or few decades back, before the advent of dish television, dish TV based television. So these kind of antennas are like quite big. They are quite large, as we see the size here, the dimensions here, the length, width, and height or thickness of the antenna. And on the right side, we can see a very small chip-based, ceramic chip-based antenna, which is of this dimension, which is just 10 mm by 3.2 by 1.5 mm, which is very, very, very small. It's like 1 centimeter by 3 mm, very small, like a grain of rice, right? So if we see both of these antennas and we get a perspective that both of these antenna works on 2.4 gigahertz, which is popularly the frequency for Wi-Fi that we use. Okay, so both of these antennas work on the same frequency, but their size is so different. It's like almost 100 times the size on the antenna on the left has compared to the antenna on the right. So why is it so? It is basically depending on the application that you want the antenna to be used for. It means the left side antenna can be used for the outdoor connections, outdoor coverage of a larger area with the Wi-Fi network, Wi-Fi signals, so that it can cover maybe tens of kilometers in a compound in a city. It will have higher gain. We compare gain in terms of the coverage an antenna can have. So with this big size, working on the Wi-Fi frequency, we can have larger coverage and more devices can be covered. But with the antenna on the right, this antenna is specifically designed for a device or a gadget which will be used for IoT, or which will be used for like smart operations or smart product. So it has to be very small, because overall the device will be very, very small. It will be just like few centimeters in size, right? So the antenna itself has to be very small compared to the device. So that's why even working on the same frequency, 2.4 gigahertz, we will be having this kind of antenna also, which is very, very small, very miniaturized, still operating on that frequency and giving its best to operate on that frequency. But it will be only applicable to a very small device, which will be connected to a local internet or local network. Can be a Wi-Fi in a home, can be a Wi-Fi in an industry building floor. So that's why it will not require such high values of certain antenna parameters. So this is just to give you a perspective that antennas can be very big working on the same frequency, and can be very, very, very small based on the application, right? So moving forward, these are the basic requirements for the antenna designs that we need for IoT specifically. I have just selected very few that we can understand, every one of us can understand quite easily. The first requirement is based on the shape and size. So it depends on the shape and size of the product actually. If the product will be a smartwatch, then the antenna can be as the one as that I showed you in the previous slide. If the product can be something that we will be using in a smartphone, the antenna can be a bit bigger. If a product can be very, very small sensor, which is like all just like 1 centimeter in size, overall the antenna has to be much smaller than the product itself, right? So it all depends on the product that we want in the end and the application. Finally, after deciding this, we can see how to place the antenna on a device, where to place and how to place. Now this point is again related to the shape and size or height of the device. How big, how thick the antenna you want to be, how long and wide the antenna you want to be in the product, and accordingly you have to have the best placement on the device, because the device will contain several ICs, battery if it is a battery operated device. There will be some other circuit components like converters, which is digital to analog, analog to digital converters. There will be some processing units. There will be some sensors itself on the device embedded all in a same platform. So we have to find the optimal placement for our antenna also, so that it will not be affecting those components, as well as those components not affecting the antenna operation. So everything has to be analyzed, optimized. Another thing is the frequency of operation. Of course, there are many technologies on which IoT products works. I have discussed few in the previous slides. So Bluetooth, Wi-Fi, and Zigbee and Z-Wave on all these names. So the frequency of operation depends on the technology that we want to use for our product. So that again decides the size of antenna and several other antenna parameters. So everything is interlinked, and overall the antenna engineers or developers has to take care of all these things. Then based on the frequency of operation, or I'll say the technology, the data throughput is another requirement, right? As per the application, what is the data throughput or data rate I need or my device will need? Is it a high data rate? Is it like high data rate connectivity that my device will be requiring? Or is it like just a sensor operation, just like a small amount of data being transmitted every now and then? So based on that, we can decide the technology, and the data throughput can be according to that. It can be several Mbps, which is megabits per second, and it can be kbps, which is kilobits per second. So it depends. It's not like we always need high data rate for everything. We will be needing very low data rate also. We will be needing very high data rate also, depending on the technology. Next comes the coverage. Now the coverage is again in terms of area that is served by the IoT device, or that we can say the IoT device can operate in. Okay, so coverage again depends the technology that we'll be using or the application domain that we'll be having. If we are using an IoT device for agricultural applications, it can be several hectares. If we'll be having an IoT device for our homes, it can be just a very small area within our home, living hall or bedroom, hall and kitchen, everything. An apartment area. If it will be for an industrial application, it will be a big plant, industry plant. So the coverage depends on the application, and again further on the technologies and the other requirements, right? Frequency operation and all. Then we have mobility. Do we need the IoT device to be mobile? Mobile means it will be moving all the time. Like we use our smartwatch, we are running, we are walking, so we are using it on the move. So it has to be it has to have the mobility or not. Or in the industry, the device are installed on several sections of the industrial plant, so it is fixed. So this also has to be decided while developing a product. So for antenna, it all matters. All these point matters, and these all need to be taken care of, and these all needs to be well optimized and efficiently designed. So moving forward with this, I can discuss briefly about all the solutions, all the technologies that are available. So we discussed about throughput and range and all those things, the frequency. So we can see here, there are some short range connectivity for small area coverage. uh, as I discussed, in a home, in an industrial plant, so small area, not like kilometers of area to cover. So first we have Wi-Fi Halo or Halo. Now this technology is simply, we have a special version of IEEE standard 802.11 AH. So here AH is being used as the first two letters, and low is for the low power operation. So this standard is specifically designed for operation of IoT devices, especially to serve IoT networks or IoT solutions. So it is working in the different domains of frequency range, and mostly in the sub 1 gigahertz range, which is like 800 900 megahertz of range. So till now we knew that Wi-Fi works on 2.54 gigahertz and 5 gigahertz band, but Wi-Fi also has some technologies or standards being developed for 1 gigahertz or sub 1 gigahertz band. The range that it can support maximum is 1 kilometer, and the maximum throughput it can support is 40 Mbps. So for high data rate communication or applications, this is really good. And the power consumption is very low. Of course, for all these technologies, the power consumption will be very low. They are designed to do that. They are designed to support low power devices. And some of the common uses can be smart lighting in the industrial plants or in the industrial compounds even. Then smart heating, ventilation, and air conditioning units that we have in our industrial plants or industrial buildings, or even our educational institutes or big universities and all those application areas, right? And for some of the security systems also within those compounds or within those areas of the city. Next comes Bluetooth, but LE, which is low energy or low power in the end, of course. So it works on 2.4 gigahertz. It supports maximum up to 100 meters, and it supports maximum data rate of up to 2 Mbps. Mostly used in mobile phones or gaming consoles or gaming devices, and also for wearables like our smartwatch or smart trackers. Another technology, which is Z-Wave, works in the sub 1 gigahertz band, supports almost the same 100 meters maximum range, but the rate is very slow for applications which don't require very high data rate. So such applications can be again smart lighting in our homes, thermostats in our homes, smart locks, smart sensors in our homes, for like presence detection and all those things, right? Then we have Zigbee. As I said, it operates on 2.4 gigahertz and has the range as 100 meter, data rate almost 250 kbps. Again, can be used for smart lighting, lighting controls, smoke detectors, CO2 detectors, which are installed in our homes. In the modern housing designs, these detectors are also there, smoke and CO2 detectors for fire detection and all. Then we have this NFC, which is, I guess, available in many smartphones these days, like from Samsung, the series that they have. So this works on this frequency range, very, very, very low compared to the others, right? 13.56 megahertz. It covers only 10 centimeter, very near field communication, very near range communication, and it supports a good amount of data rate, around 424 kbps. And it is mostly used for commerce application like payments through your phones, right? Without having your card swiped and all, and in your smartphones and automations and all, right? So these are all short range connectivity. And we also have applications which requires long range connectivity. Again, IoT devices being deployed there, operating in kilometers of range and radius. So all these common names like GSM, which is 2G, then LTE category 1, then extended GSM, which is specially for IoT. They have designed it. The ITU has specially designed this standard or developed this standard for IoT. Then LTE category narrowband 1 for narrowband IoT operations. A specific LTE spectrum is assigned for this. LTE category 1 for machine operations, as enhanced machine operations. And then we have long range wireless wide area network, which is LoRaWAN. And then we have Sigfox. So out of these, the GSM and 4G LTE networks are actually operating in different spectrums depending on the region. Region here is the country, because different countries have their different spectrums assigned by ITU, International Telecommunication Union. They can operate up to hundreds of kilometers, and they have all these variable of speeds. All these technologies have these kind of data rate that they support. But in terms of 2G, we can say that it consumes, the devices consume higher power because of the whole structure or architecture or operation of this technology. So these can be used in smart metering or asset tracking, like in the tracking and uh, delivering businesses, and also for some sensors. Then we have the enhanced GSM or LTE standards, which operates consuming low power, and they can be used in hospitals like for health monitoring, smart cities, as it can cover the whole city, right? And also some of the sensors which are deployed in like a very large area. Now these two technologies are covering larger areas, but they support very low data rate. So they are for the applications which does not require a very high data rate support. So this long range wide area network operates in sub 1 gigahertz range, which is again like 900 megahertz or 800 megahertz. It can cover this much of area, and data rate is very low, as we can see, and the power consumption is also very low. So in that sense, the devices can be there for a very long time, maybe years of operation can be obtained from such devices operating in this technology. So these can be used for logistics, utilities, can be used in smart cities, of course, which can be installed and for years they can operate before replacing them. Of course, in industrial IoT, which we also call I square OT or IIoT. This is the term that we are using these days. So on industrial IoT also, these technologies can support to have IoT enabled networks there. And Sigfox is another popular technologies being used or being deployed in asset tracking, mobile health, e-health, or remote monitoring of certain parameters. So moving ahead with all these technical things or technical terms, let's go in the application area. So here we can dive into some interesting things which are there in the market, which are given to us by some of the researchers. So this first one is a living IoT example of having a living thing carrying an IoT device, which is here a bumblebee, honeybee, we can say. So some researchers from University of Washington has developed this a few years back. They have proposed this thing, having an IoT device attached to a bumblebee or honeybee, and through which they can monitor the surrounding areas. They can have the localization, behavior of the honeybee studied, and they can also have some other parameters being observed as per the sensor installed on the IoT device. So initially they installed like temperature sensors and some localization sensors. So here we can see a comparison of this IoT device, the size of IoT device compared to a American cent, only 1 cent coin, and zoomed in version of this device that they developed. There are some switches, an antenna present here, and a processing unit, microcontroller unit, some more components here, electronic components, and some sensors here. This is actually a temperature sensor that they use. So overall weight of this circuit, this device, is only 102 milligram, and out of which the battery that they had to use is covering most of the weight. So it's like 70 milligram of the battery that they had to use, and it's a rechargeable battery. So for the antenna, if I'll focus here, for the antenna is like a wire antenna, which is like having 7 turns and then long wire being there. So this antenna operates on a certain frequency, is like 2.4 gigahertz, and through which it can transmit to the nearby receivers, and they can get the data from the sensors. So wherever the bee goes within the 80 to 100 meter of radius, they can get the data from it. And to charge the device, they had some solutions for the battery. So to charge the battery, they use the RF energy harvesting concept, like RF charging concept, which we are using these days for our mobile phones, right? So for this battery, they also developed this kind of a thing, RF charger, which wirelessly charges the battery. They also proposed like another thing, to have a solar panel, or very small, like almost this sized solar panel installed on a PCB, and through which the battery can charge, or through which the device can operate. So in a sunlight environment, sunny environment, the device can operate through a solar powered circuit also. So there is no need of battery, and the weight of the battery can also be eliminated from the device. So now the question arises, what about like the animal rights? The agencies comes always like to save the animals from all these machines being installed on them, or they are being monitored or tracked. But actually there is this institutional animal care and use committee, which has some guidelines, and based on that or following that, they had done this experiment. And it's not like the animal or the bee has to carry a heavy thing or a heavy device. They are capable of, or they are used to carry this much of weight quite easily. So it's not like they are carrying a heavy thing all the time with them, or it hinders their day-to-day life or their day-to-day operations, right? Flying and everything. So the device was also optimized as per the flying pattern of the bee, and the bee can also carry. The bee is capable of carrying this much of weight. So there is no interference between these two things, an IoT device and a living thing. So moving ahead, one interesting application. Another one is smart agriculture. This is also like coming up as a buzzword these days. So this is just a brief example I took, which is having a greenhouse which is smart. So in this basic description, we can see that we have some cloud infrastructure, which is like connected to internet and all. And then we can have some remote commands through it, or we can use smartphone to remotely give some commands or operations. And there will be a gateway which will be wirelessly connected to the smartphone as well as the cloud or internet. And monitoring can be there. The data or the sensors which are giving us some data can be monitored here after processing. And finally, the connection gateway can be connected to the greenhouse, which has some sensors and actuators. As I told you, IoT requires these, and further some controls and switchgear, which is like to operate the devices and stuff which is there in the greenhouse. So what are the sensors? They are like sensors to see the light in the greenhouse, to see the air flow and air quality, to have the blowers or fans being operated there, and for the water to use the pumps and all whenever required. So based on the data from such sensors like light, humidity sensor, For air, there can be air quality sensor and all. So based on the data from these sensors and processing that data, and also referring to the acceptable values and values that we need always in a greenhouse, we can have that monitored, and accordingly we can give commands to operate the actuators, which is like the blower, fans, the water pumps, and the lighting units. So all of this can contribute to have a smart agriculture. It's not like a person has to be there all the time, to go there multiple times a day and check carefully, physically, everything, if it's all working fine. So this can all be done. And another addition that I also thought of is to have a camera, which is enabled through backed up by a AI software, through which you can observe the crops, the plants inside, and you can always see the health of those plants, how they are growing from time to time. So the analysis based on artificial intelligence can also be done, which is based on machine learning, right, in the end. So this is also another interesting application. And next we can move forward to an application which I am linked with. Here in my institute, I'm working on train communication system, specifically for antennas, of course, but I know the overall idea and how the project is going on. So in our project, as well as in some other research institutes, they are talking about this term, train integrity. Now, I'll briefly give you an example of what it means with an example, right? So we have our train coaches traveling from cities to cities. They have multiple coaches and engines, right? So what if we have a train which carry cargo, right? So those trains, freight trains, we call them. So those trains have a large number of coaches having the needed cargo being carried between the cities or between the industrial plants even, right? So they have even 50, 60 or 70 coaches, train coaches connected to the engine, and they are traveling, right? But what if, and this is a real scenario, what if while being on the journey in between, because of some mechanical fault or some mechanical accident, one of the coach gets derailed or gets disconnected from the train body, and the train continues its journey because there is only one train engineer or train pilot in the engine room. That's it. No one is observing anything from the on the other coaches, right? So in between the cities, what if the train coaches, maybe 3 or 4 or 10 of the coaches in the end of the train, gets disconnected from the train, and driver will not be knowing that for a long time until it will reach to next station, and the driver decides to count the number of train coaches, right? So to solve this problem, there is this concept of train integrity. Integrity here means to have the train connections, the coach connections, checked all the time to be sure that they are connected. So for that, we have the onboard train integrity device, which is OTI, installed on all the coaches, and then connected to a ERTMS system, which is actually a European standard, European Rail Traffic Management, which has several circuits or several communication networks through which the train operators can connect to the train. So what does this OTI device has? It has some onboard sensors like proximity sensors. So if I say I'll install OTI here and here on the ends of a coach, and the OTI system, OTI device communicate or kind of have a connection through these sensors, which can be based on proximity detectors, which can be based on a RFID antenna, RFID system, or can be based on the UWB, ultra wideband pulse-based system. So in this, they continuously transmit pulse, and the other system can receive that continuously. And if this stops, if this connection stops, so the driver can be right away informed or alarmed about the situation. So well in time, the coaches can be tracked or can be known that if they are connected or not. And further, to strengthen the whole concept of train integrity, there can also be another onboard system, which is GNSS, which is Global Navigational Satellite System, in which we have GPS, Galileo, or Indian navigation system also, which India launched a couple of years back. So this can also be used for satellite-based positioning or localization of trains. So with this and the local sensors, a very secure and safe way of getting the train integrity checked from time to time can be obtained, can be achieved. And this is what is being developed and what is being explored in our project, in the project that I'm attached with. Some other researchers and partners are working. The companies, railway companies of Europe are contributing in that, and they are developing systems and solutions for it. And so this is like one of the application, industrial IoT, I can say. IoT on the train, because we have sensors, we have data on it, we are getting the data, processing it, and analyzing the data, and based on that we act, either to either to obtain like the information, okay, the train is all intact, it is all integral, or if there is any problem. There can be some sensors on the railway wheels also, to have it checked for the mechanical wear and tear. So there are so many solutions being explored, and they will be coming up in the near future on the railway systems. We'll be seeing them to have our journeys being more secure, being more efficient in all way. Okay, so these are some of the interesting applications under IoT. Next, another important term that I came across is, and I just want to touch upon this thing, which is Internet of Nano Things. So IoT, another term out of IoT. So it's just like based on the nano sensors. That's why Internet of Nano Things. We can have some sensors which can be inserted inside the human body to monitor, to test some of the human body parameters, such as blood pressure, oximetry, which is for oxygen levels, glucose levels. So all those sensors can be installed, and they has to be very small. So that's why nano sensors, and they can communicate with the local gateway, with the local device that we can have with us, and then further it can transmit the data to the internet. Further, that can be shared with the healthcare provider, doctors, hospitals, and all. And in this way, a healthcare monitoring system can be developed. So that's why this term came up, Internet of Nano Things, because we have multiple sensors in the body, and that all communicate with the internet and external world. So we use nanosensors for all these monitoring, and I guess this is actually the current area of research being worked on, and we'll be seeing some of the solutions in the coming years for this also. So that's quite interesting to work in this area also. So next we can move on on a special case of IoT, which is wearable antennas. So we are all using these, actually, the wearable devices, I will say. We are all using these. In the last couple of years, we came to know about all these things. The smart watches are the most popular ones. Then we have the smart trackers, Fitbit and all. Then we have some other kind of devices which we can wear in the shoes, which we can have on our shoulders, and smart clothings and all. These are also coming up. In the hospitals, they have those smart clothings on which the sensors are already installed, and the monitoring can be done quite easily. In the military applications, they are the first ones who work on these technologies and who came up with some of the solutions, which further comes into the market, commercial market, right? So the military guys can also are also having so many solutions with them for their soldiers, to monitor their position, to monitor their vitals, to monitor their video surveillance and all. They have all sorts of installed devices on their clothings, right? So wearable antennas, in that we can start with the basic introduction to the body-centric communication. So we have three divisions in this. So when there is a networking between humans and human to human communication, we have. So we use some wearable or implantable devices.
Sorry for the interruption.
Yes.
Naveen sir, sorry for interruption.
Yes.
There is a question from Radhika Chintamani. What
Yeah.
signals they pick up, electrical or pressure signals?
I guess they are talking about the in-body sensors, right?
Yes, sir.
I guess they are okay. So as in the previous slide I showed, there is this ECG, which is the electrocardiogram signals, which we use the external device for. The doctors uses the external devices. So the internal sensors can be installed to pick up those signals from the heart. They are electrical form signals, right? And those signals can be transmitted in the form of data to have them visualized externally. So in the human body, there can be different kind of signals: electrical, they can be magnetic, there can be some chemical-based signals through to which the sensors should operate. The sensors will work as per the type of signal. right? So the oximetry sensor can be a chemical sensor which detects the oxygen level. The glucose detection sensor can be chemical based sensor which will detect the glucose level. So those kind of different signals inside the human body can be detected with different kind of sensors. So this is how it works. So I hope I answered briefly the query. So I can continue, I guess, and later we can
Thank
have
you
some
so
more
much, sir.
queries in
I'm
the question
sure.
and answer
Yeah.
session. Okay, thank you. So moving ahead, we were talking about body-centric communication. So here we have the three domains or three categories. And Professor Yang Hao from Queen Mary University and Professor Hall from the same group, they are working in this domain very extensively. I will say in the last one and a half decade, they have been contributing to this field quite extensively, and they are giving solutions actually to the industry also. So there is this categorization of body-centric communication, which is on-body communication, like having different sensors or devices which we wear on body. It can be in human body or outside the human body on the clothing and all. Then we have off-body communication, which is like these sensors on human body communicates with some external points like wireless access points or some cellular networks. And further, the third category can be body-to-body communication. So two human beings or many persons can communicate with each other through these sensors, sharing the data, and finally, the data can further be shared to the network, which can be a wireless network or a cellular network. So these are the three domains, and we also name it in this term like wireless body area network, which is this, having a network formed on human body. Then we have wireless sensor network, again some sensors in or on human body forming a network. And then we have wireless personal area network. So humans having some sensors on body as well as some devices around them, like their smartphones, their laptops, or their uh, tablets and all. So all being connected to internet. So that forms wireless personal area network, right? So these terms are also quite popular and technical terms which are being used in this domain. So moving ahead, what are the popular frequency bands which are being used for the body area networks or human body communication systems? So we have this MICS, medical implant communication system. This, as the name uh, suggests, this is specifically the band to have some implant based sensors or devices. When we have to implant like capsules or some small devices inside the human body, under the skin or in the human veins and all different parts of the human body. So this is the band which is most popular or being assigned by the authorities. So this is medical implant communication systems based on this frequency band. Then we have the license-free band of industrial, scientific, and medical domain, which is ISM, in which again there is some frequency around 400 megahertz. We can see there is a frequency band of 900 megahertz being assigned, and this is at the higher frequency range. So these three, if you see, are actually the bands for Wi-Fi, are actually the popular bands for Wi-Fi that we use in day-to-day life in our devices. We have these frequencies being used. Then very interesting technology or frequency band is ultra wideband, and this is especially for those applications which supports higher data rate, very high data rate applications. So ultra wideband is assigned by FCC or ITU, the authorities, to have communication systems or devices being developed to support high data rate communication and short range communication. Another thing is short range communication using this technology or this range. So it's a very wide band of almost around 7.5 gigahertz, very wide spectrum only for this application. This is actually a pulsed application, pulse-based application, narrow pulses. Then we have very popular 2G, GSM, Global System for Mobile Communication, working on these bands popularly. Then we have personal communication services, again comes under 2G, but we use them for several other applications in this band. And finally, a new entry to this band recently in the last years is Y-Gig, or we can also call it a millimeter wave band at 60 gigahertz, a very high frequency. And using this frequency, we have a very large bandwidth available for the communication, as well as the device size can be very small in terms of millimeter, I will say. The whole device can be just few millimeters in size, because this will go into IC technology. We can have everything being developed in the integrated circuit technology. So this is also being explored and used for many applications, this range, especially for body area networks also. So moving ahead, some basic requirements, although the requirements that I already discussed for IoT also applies here, but some additional requirements for wearables can be the form factor. Now here the form factor again covers the size, shape, weight of the device or of the antenna in which it will be used for wearables. So the form factor is very important. The overall weight, overall size and shape we have to consider while designing an antennas for these variables. Then the antenna gain and efficiency. So based on the technology, if we want the variable to just communicate with our mobile phone, and that is with us, right, or within our room, quite shorter distance. So the gain doesn't have to be very high. It can be very nominal gain, 1 dB. We call or we term gain in dB. So 1 dB, 1.5 dB, even 0 dB works. 0 dB. Now gain is actually the radiation of antenna in a particular direction. It's not like the signal is being enhanced. Gain is simply an antenna which radiates higher amount of energy in a particular direction. So we say antenna has a gain or some high gain in that direction. And also the efficiency. Now this is very important. I'll briefly touch upon this term. Antenna we design, antenna engineer designed the antenna, but when the antenna is installed or being worn by the human on their body, on the shoulders, on their hands, the antenna parameter changes, the antenna properties changes because of the human body interactions. So the efficiency also
Uh,
reduces, and this efficiency,
Sorry
yeah,
for the interruption.
yeah.
Sorry for the interruption, Naveen sir. Actually, Raksha has some doubt. How did the experts know the bees were at ease with the foreign body?
Okay, so first of all, as we all know that some of the trials were has to be always conducted while experimenting with the living beings, right? So they had some trials, and they have the studies with them from the biologists and all those areas, people working in other areas with animals, like how much weight a bee can carry, and if they install something, what effect the bee can observe or that the bee can experience. So going through with all those studies, then further they decided to have their experiment continued. So moving ahead is to have analysis from the biologists, doctors, living being experts, and also from the authorities, the guidelines from the authorities. So based on that, they moved ahead with all that experimentation. So I hope I answered the query.
Thank you so much, sir.
Okay. So continuing, I was telling about efficiency. So antenna, okay, we designed the antenna, we installed the antenna in the device. But when us, the humans, wears the device, have the device on us, maybe a wristband or a watch. So our human body, the skin, the fat, the tissue, the bones, have different compositions, and that affects the antenna operation. And that effect can be observed in terms of reduced efficiency. The antenna efficiency gets reduced, and further this affects the power consumption of the antenna or whole device. So in that sense, we can say that a lower efficient antenna or a lower efficiency device will consume more power. So the antenna engineer should also take care of this requirement very carefully to have a higher efficient antenna, even in touch with the human body. Even if it is installed on human body, it has to maintain some higher level of efficiency. Then we have this important parameter. If us humans are wearing something which is like electromagnetic, which radiates and receives, so there is this term specific absorption rate, which is the absorption of electromagnetic exposure or energy by our human tissues or human body. So these considerations or these values are already defined by FCC and ITU and these are available online. For mobile communication, the level that is there is 1.6 watts per kg of human tissue. 1.6 watts of uh, this exposure per kg of human tissue. So that is the allowed level. And in all of our mobile phones, our watches, smart watches, and wearable tech, this level has to be met by the manufacturers, by the companies, right? So as of now, for mobile communication, the level is this. Although for IoTs, I'm sure they will have much more strict guidelines or levels, lower levels of exposure, so that it will be safer for longer use by humans, right? And the antennas has to have the flexibility in terms of, like, if we install the antenna on our shoulder or on our wrist or on our legs, it has to be flexible. It has to have the flexibility of bent sometime, or being crumpled, being pressed sometime, but still operating stably or operating in a proper manner. So these are some of the requirements in terms of antennas while we design it for wearables. Now, this is an example of devices working in short personal communication networks, or personal area networks, we can say, wireless personal area networks. So if we see in these examples of these figures, so if we see, there are some Wi-Fi access points, base station of cellular as well as Wi-Fi technologies. We have some mobile phones, laptops, PDAs. So all these being connected with each other as well as connected to the network. So this forms a wireless personal area network. How? For this lady, we see there is a mobile phone, there is a laptop. So if they are connected, this forms a her personal area network, either via Bluetooth or Wi-Fi. For this person, his personal area network, and so on. And further, if all of these are connected with each other, this forms a personal wireless personal area network as a whole, right? So this is how a scenario can look like in a personal area network or personal communication network scenario, which is of short range. We can see it's a very small area on an airport or somewhere. Then we talk about like on-body sensors or on-body communication by wearables. So we can have several devices, sensors on a human body for blood pressure, oximetry, ECG, some artificial pancreas being installed, EMG, and some inertial sensors or movement sensors on our ankles, or several other sensors. You have a lot of them. So they are being installed there, being connected to the network further through a device, either via Bluetooth or some other technology, and also to the internet, so that the data can be stored or being processed by the healthcare professionals and others. And right away, we can also have the visual feedback on our device after the data being processed from these sensors. So we can see all these values. And what does it mean? Is it high? Is it low? So, and accordingly, we can consult to the healthcare professional. So this is just a brief example how this healthcare tech can work, having a wearable based network, right? Moving ahead, the brief areas that a few of those I already discussed can be in military for sure. I guess every one of us know military people are continuously working and developing and researching about all these technologies they are using even before us. Then it comes to our commercial market. Then healthcare for sure. Then sports, educational industry, industrial control for research for sure, fashion, agriculture, and transport. As I touched upon on few of these areas already in the previous slides. Yes, Priyanka, any more query? I guess.
Sorry for interruption. Again, sir, Raksha has a question, I guess. He just wants to know. What's your opinion on the debate and negativity about 5G going on worldwide? And he has one more question. Can you give some
Okay.
evidence using nanometer use signal captured electrode in medical field?
Okay. Okay, I'll answer the first question, and I guess second question I was not able to hear it. So I guess in the end, I'm just about to finish. In the end, I can have that question again, the second one, right? So the first question about 5G or the negativity or the fake
Sure.
news, I will say, being spread by many people around the world, especially in UK. I have seen there was some destruction of 5G sites also, 5G antennas also. So it's actually all fake or all rumors, I will say. 4G is already being used by us, right? We have already all those sites, mobile sites and antennas around us, and we are using it very easily, very effectively. 5G is just being installed on those sites mostly, and the areas which requires higher number of connections or higher data rate, there will be more number of antennas in those areas only. There will be more number of installation in those areas only, and still the frequency of operation will be same as 4G, 3G, 2G. So there is no difference in the frequency of operation. Even the power level should be low, will be low. This is the main focus of 5G, to have low powered technology standards. So the energy coming from those antennas around us, even from our devices, it will be lower actually compared to 4G. So in all sense, 5G will be much more efficient, much more advanced, and it will be low power technology. It will be low energy technology, and it will not have that much exposure, EMF exposure, which is electromagnetic exposure to humans using that technology. So it's all actually, I'll just say it's all rumor and fake news that is being spread. So I guess rest of the question I'll just take in the end. I'm just about to finish in, I guess, few minutes.
Yes, sir.
So I'll just continue with the next
Sure,
slide.
sir. Thank you so much. Yeah,
Okay,
sure.
so few applications from wearable point of view. So just few minutes, 5 minutes more, guys. I guess it is interesting, but I'll just continue with a few more interesting applications. These are some of the works done by some researchers around the world and being published online. The references are there at the bottom of the slides. So this is actually a body wearable antenna used for medical, which can be used for medical applications for elderly as well as ICUs and hospitals. So this is a printed antenna on human clothing. So we can have this as an option, and some device which will use this antenna, although it looks big. But of course, some research work can be done and is already being done to have it miniaturized. Then we have some capsule-based antenna which can be uh, inhaled or taken by the human, taken by us, and inside the body it can transmit the required information, either the oximetry level, either the glucose level, either the blood pressure level, any kind of observation. The sensor which is installed in the capsule, having this antenna also, can transmit in terms of pulses. Here we see we have a UWB pulse generator, so it can transmit in terms of a pulse-based communication, and the data can further be processed and viewed. And then we have another interesting application to have a smart clothing or antennas or systems in our clothings. So personal communication can be achieved through that. We can have a jacket which can have some internal cellular board or Wi-Fi module, and we can have some antenna through which we can transmit some of the vital information, or just for communication. It can be for both. So for personal communication also, this kind of arrangement or some research was being presented in the last few years. Next, we can go ahead with some interesting things like the antennas, which are based on the clothings. Like we use polyester, right? We use these threads to design our shirts, t-shirts, and all those clothings that we use. So we can have conductive threads. There is already availability of conductive threads through which we can have the embroidery done in terms of antenna shape, and that antenna can be excited by some signal and it can operate very easily. So this patch of a cloth can be installed on any t-shirt, any polo, any shirt, any trouser quite easily, and it is a clothing material. It's not like there is something conductive, there is something which is not fabric or textile. So it's like a conductive thread or conductive clothing, we call them, and we can use some basic embroidery machine using the thread to have different shapes of antenna. So on the right also you can see there is some conductive thread being used to create a shape of an antenna, and there is some excitation or IC through which it can form an RFID system. This is actually an tag, RFID tag, which we use for identification or detection purposes, right? So this can be installed on our clothings, and it is a natural material which is like a thread. clothing, which will not be, I'll say, which will not be uncomfortable also for us to have on our clothings, right? So this is an interesting area in which the antenna engineers are also operating in. Although it requires the knowledge of material science, people from physics, and all those things. Of course, the contribution should be from all the other areas. And then we have these applications, which is again quite interesting. We can have some special printers and special inks to print the antennas. It's not like we have to have a very costly printers or industries to have the antenna manufactured. We can have the home printer kind of thing, and we print the antenna shape and have the connector and connect it to the device. So this is like a on-the-go kind of a printing or designing of antennas. So these are flexible, printable, as well as low cost for like RFID and wearable tech. Then we have some biocompatible, biodegradable antennas for biomedical applications or implants. This means these will not be foreign materials for human body. These will be like can be biodegradable, or these will be compatible biologically. So some of the inks are being developed in that area, and some of the threads also are being developed. Then we have these optically transparent antennas or reconfigurable antennas. Here on the right, you can see the latest product proposed by AGC Glass, a company which manufactures glass bus, but it also works on the technologies which they can incorporate in the glass. So they are coming up with the 5G base station antennas. They are coming up with this silica glass antenna, very small transparent antenna, which operates on 5G. And they have a little big antenna which can be installed on a glass, which is transparent, and it can support 5G signals. It can transmit 5G signal to that floor or to that building. So in this way, you will not be having some aesthetic obstruction, aesthetic, I'll say, misconfiguration in your building. You have a glass building and you install some router or something, and it will obstruct the view also, or it will not look good aesthetically. So aesthetics are also important in our homes as well as industrial buildings and all. So that's why they are coming up with this glass-based antenna, which are transparent, right, mostly. So this is quite interesting. And finally, as I touched upon the SAR analysis, so this is some work from my research group in Thapar University. This is my work that I already published and did, and actually this is being done by many researchers around the world. So this is to analyze the absorption, exposure of the antenna being designed, or the absorption by the human body. So these are the models. On the left, you can see the model of human body in the flat domain. This is like a cylindrical model to like model the human wrist or human upper hand and human thigh and human lower leg and all. And this is the model for human head and hand, because mostly the mobile phone on the right, you can see an industrial physical model of this simulated model. A human head filled with fluids which are having equivalent properties as our human brain has, human skin and tissues has, and also human hand, which inside is filled with the fluids which are having equivalent properties as our human body fluid has. So having these done during simulation is very important to know the level of absorption, to know the level of SAR, as we call it, 1.6 watts per kg. It has to be lower than that. So these kind of analysis should be done already, so that your antenna, at least in the simulation level, can confirm these standards. And while manufacturing it, having it prototype, you can have the physical measurements also, and with that you can confirm that the antenna is ready to be used on human body and by the humans quite easily, without any fear of like the exposure and all. So with this, I can conclude the presentation. I guess this gave you an insight about all these IoT and wearable tech and antennas. So it has a broad scope and social implications, social constraints. It has limitless applications for sure. There are a number of devices and areas which are coming up, which will come up using IoT and wearable tech. Wearable electronics is a very hot topic these days for many domains, research topic for material science, physicists, electronics, computers, even mechanical civil people who are working on like transport and all, where they have to install these systems also. So that's why it is interdisciplinary. topic. So with this, I conclude my slide, and thank you very much. And very briefly, I'll just give you information about this conference which is coming up. I am associated with this conference, which is International Conference on Electronics, Telecommunication and Information Processing, which will be organized online. It will be a web conference, and this is the submission deadline. So I invite you all to contribute your research and studies to this conference. So thank you very much for your time. I hope you like the whole presentation and talk.
Thank you very much,
So
sir, for this wonderful session. Yeah, so we have some more questions. Can I, will you able to
yeah,
have the query questions?
yeah, sure.
Okay.
I'm available.
So,
Available for the
yes, sir. Thank you, sir. Okay, Mohan has a question. Would you please highlight on security consideration in home automation?
in home
Security
home automation,
consideration in
I'll
home
say,
automation.
yeah, home automation. Yeah. So in home automation, or we say the devices being connected within our homes with each other or with the network. So the security constraints or privacy concerns will be the same as we have currently with our Wi-Fi networks. So Wi-Fi networks, not to make them open, even being used within our home, not to be used by people around our home or people who are nearby our home. But for the devices inside our home, there are not many security concerns as such, because we are using the devices mostly within our home with the network, which is the Wi-Fi that is being used by us. But for that Wi-Fi network, we have to be sure it is secured with all kinds of passwords and security parameters.
Okay, yeah, thank
Okay,
you, sir.
so
So
next
our
question.
next question is from Narendra Singh. Yeah, he's saying, how can we minimize the side effects of radiation as we are becoming heavily dependent on these devices whose working depend on signals or electromagnetic waves?
Okay, very interesting question. We all, as a human being, we are all concerned about this exposure, absorption. What does the device uh, has an effect on our body and all, right? So to reduce the effects or the exposure or the absorption by our body of these signals coming out of the wearables, the mobile phones and all, the proposed techniques which are there available in the market is specifically for antennas. For antennas, we can have some reflecting surfaces. We can have something based on metamaterials. This is another interesting topic, another interesting domain. So using those, we can have the energy being transmitted away from the human body, not towards the human body. So this is one of the ways, and we can have some kind of a absorber between the device and human body so that the electromagnetic exposure can be minimum, so that it will not affect much.
Okay, thank you so much, sir. And we have one more question from Raksha. Actually, a lot of questions from Raksha. She's asking, then why are people so concerned about 5G and creating issues?
Okay,
And also, what
so
are the
yeah,
social implications?
okay, so yeah, I know that people are having this in mind who are, like, I'll say, general public, who are not connected with the technical terms and technical know-how. So people are creating this rumors or this kind of a mess, like destroying the sites of 5G uh, s- communication systems and all, because I don't know, they want something to be created against the technology. They think that new technology is not good. New technology will be bad in terms of the radiations and all. But as I told you earlier, it will be having lower power, lower radiation constraints compared to 4G. So with 5G, it's not like it will have very high power. We have to have a very large amount of devices being supported. So there has to be many antennas and radiating in high power signal. So this is not the case. It will be almost similar to 4G network and much better than that, much more efficient. Okay.
And our next question is from Raksha as well. What are the social implications? She's asking
Social
about social
implications, I'll
implications.
say, yeah, this will, I guess this is, and this will be a point to be taken care by the manufacturers and telecom companies, because if, of course, in areas as I told you, where more number of devices has to be supported, higher data rate will be required, so there has to be more number of antennas for sure. But the antennas will be very small, of course, and they can be installed on the light poles, on the signboards or traffic lights in our localities and all. But of course, there will be a more number of antennas around us. So the manufacturers and telecom operators should take care of making them aesthetically good. They can be like well, I will say, camouflage in our surroundings, so that they will not be visibly, I'll say, not good to see all around us, antennas and antennas and antennas all around us. So in that sense, the social implication will be the I'll say, human thinking. It will get affected, of course, if we'll see antennas around us, we'll see it's a lot of radiation we are having. Again, the talk will start, why we have so many antennas around us, why there is so much exposure, and there can be some agitation for that. So these are some of the social implications that the companies has to take care of, and they have to think.
Yes, sir. That's all for today. I guess all the our audience get all their answers. And thank you once again for such wonderful session, Naveen sir. It was indeed great pleasure to have you as an expert.
Thank you very much to the organizers. I'll repeat, to have my thanks to Tech Counselor and Tulas Institute, and also to the organizers for inviting me. And I'll look forward to the future talks and future events by you. So I hope everyone is
Sure,
staying
sir.
safe and taking all the precautions, and stay at home as much as you can.
Yeah. Thank, yes, sir. Thank you so much once again.
Okay, thank you
Thank
very
you for
much.
your valuable time, and we will conduct tomorrow 1 p.m. again. Thank you. Thank you so
Okay,
much.
thank you.
Yeah.
Thank you. Okay then. Bye everybody.
Bye.